What's up, guys? We're in Albany, Oregon. It's raining, and we're at Concept Systems. Concept Systems is an industrial automation company. Who doesn't love robots? We're gonna take a look inside at how they integrate robots into the food industry, aerospace, and tons of other cool stuff. I spent 15 years in the manufacturing world, and now I'm on a mission to show people how things are made and excite the youthful generations to get them involved in this amazing industry. This is Manufacturing Tribe TV. What's up, guys? We're here with Ryan Wasman, the Sales and Marketing Director at Concept Systems. Ryan, what is it that you guys do here, and what are we going to see?
We're an industrial automation company, so you're going to see how we build panels, we build robotic cells. You're going to see lots of cool things that we build for manufacturing.
Cool. Let's go take a look.
So this is our shipping and receiving department. This is where all of everything starts.
Okay. So you guys get all your material in here, where everything from the nuts and the bolts up to the robots come through here?
Yeah.
What works through?
Yeah, so as we go through and design something, then we'll put a bill of materials together. That bill of materials gets sent over to purchasing. They'll go through and start buying everything for that specific project. It comes into this location and gets kitted for that project. And once that kit's built out, then it moves onto the manufacturing floor.
So then even the big robots, do they come in and stay here, or do they, do you guys have to move those into a different location?
So they'll come in here, and once they're here and all the pieces for that project are here, then we'll move it out to, we have a second building where we do a lot of our mechanical builds. And we can see that in a little while.
So do you guys have any robots in the crate still that haven't been put together that we can see?
Yeah, actually we have a robot over here that's actually being set up to get shipped out. So this is a paint robot that we've built a paint platform around.
Oh, wow.
Yep. So this is a paint system, and the claim to fame with this one is it has a really simple, easy to use interface, so we can push programs out via the internet. So we don't even have to be on site to program this robot.
Wow.
So it's helpful for general industry customers that don't know robotics programming.
And so from a robot standpoint, from my knowledge, different axes, different ways to control it. How many axes are on this robot?
This is a 6-axis. The term is 6-axis articulated arm.
Okay, so what does that mean?
So it has the ability, it's a 6-axis robot, but it has the ability to move in 6 degrees of freedom. Okay. So a point in space, it can move in X, Y, Z, and then it can rotate around X, Y, and Z.
I know that you guys don't manufacture the robots, but with the panels, do you guys do anything with those? Anything custom or make those yourselves?
Yeah, actually, on this in the back, you can't see it, but I've got a good example over there of panels that we build. This has a panel that we've used to integrate the robot controller, the touch panel, and some of the electronics that go into getting the data from the cloud.
Okay. So with the panels, are you guys doing them all from scratch based on the application, or do you guys have a set standard way of doing things?
So, well, we have a set standard way of doing things as far as the methodology goes. We build our panels according to a best practice. But for certain things, we'll have the completely custom design panels. Some customers call us up and say, we need this panel design, or this panel built, and we'll build that panel from their print. We have an entire design group that can design these panels as well.
Very cool. All right, let's check out these panels.
Yeah.
Explain to me what's going on here.
So you can see these panels, these are actually being installed in an environment that needs purged air, that needs There's no paint on these panels because they're going into an explosion environment. So you can see we've laid out everything in this panel. So we've got drives, we've got transformers, we've got all the wiring relays for this. In this panel, this is a great example of a custom design panel we've built to a specification.
So do you guys, I mean, so these things are parts that came in through receiving that you guys don't make, but you guys started with basically a blank box.
Yep.
And built this out and organized all this stuff and assembled it?
Yeah. So based on the customer's requirements, they're gonna tell us, hey, we need to control this thing. It's gonna go in this type of environment, and from that, we'll design it into like this type of enclosure is a different NEMA type enclosure. There's NEMA 4, NEMA 12. So we'll pick that style of enclosure based on the environment it's going into. Okay. We'll make sure that the electronics that are going into it will control it to their specification. This is all from scratch. So we start with this back plane and it's blank.
Wow.
And we have a design group that will lay out the entire back plane, make sure there's spacing for the components, make sure we take into account heat loads, ambient heat temperatures, so that we're not putting this into a 90-degree environment and it overheats, right?
Yeah, that wouldn't be very
good.
Right? So what's the range of environments talking to that? I mean, what type of environments could these be in?
We've done systems for washdown environments, so like food and beverage typically is has to be washdown capable.
Is that where they're hitting it with a hose and cleaners and things like that, or?
Yeah, where it will get wet. I mean, it's not meant to be directly water poured onto it, right. But it can survive in a washdown type environment or a clean room type environment. We've done panels for hazardous environments. We've done panels for explosion environments. And then just your regular panel.
So it looks like these are ready to go, because I see some others that are half built and being processed. So are these ready to ship, or what's going on with the location of them?
So these are built, but they're not tested yet. And so they're in this spot and they're open like this for panel checkout. So we go through a whole QC process. We make sure that every single wire is tight. We make sure that everything is in place. And then we've got engineers that will actually come out and plug into the panel. They'll make sure it's working. They'll make sure that it's landing at the customer's site, working, ready to go, ready to be plugged in.
So there's like the final test before it gets packed up and shipped out.
Yes, exactly.
All right, so then we've seen the panels. We saw a raw robot come in. Now, putting those two together, what do you guys have to show where you can see both of those two aspects interacting?
So if we walk over to our Bay 3 of this building, or Building 2, which is a separate building that we do a lot of the system builds, you can see these panels attached to robotic cells and some other things.
Okay. So what types of applications or things do you guys work with the robots?
So we work in a lot of aerospace applications around paint. We work in a lot of smaller general industry paint applications. We've done a lot of assembly applications with robotics. We've done a lot of machine vision guided robotics for some cutting, some deburring solutions.
Okay.
We have some collaborative robots that we've done work with, where somebody's working side by side with the robot next to them without safety in place.
All right, Ryan, so what do we have going on over here? I see a couple robots and some controls.
Yeah, so this is an assembly cell, multiple robots in a small area with an 8-second cycle time, assembling some electronic components. So this is actually a piece of assembly line. The other pieces are actually being built in a different facility in the Charlotte office.
Okay.
So this will connect up with 2 or 3 other pieces to make an entire start to finish assembly line for electronics components.
And I see that these are some smaller robots. I mean, from my experience being in the industry, I've seen ones that are bigger. Do you guys deal with ones that are like our height or above?
Yeah, so we've installed small robots this size and even smaller, up to we've done a 2,400 kilogram payload robot that takes up, it needs a 20-foot ceiling just to operate.
Wow. So what do you guys have here that we can see from a size standpoint?
We have a mid-sized robot cell across the street if we wanted to go over there and take a look at that.
Yeah, let's go look at that.
Yeah.
All right, so that's what I'm talking about. Bigger robots, Ryan. What is that?
So that is a FANUC, I believe it's an M710. It's a bin picking system for a customer that wants to put an entire bin of parts in front of the robot, have us find the top pieces that we can pick, and then we're picking them and then we're doing something with them. And then we return them to the bin comes out.
So then it looks like, I see you got 2 sample bins here to mock it up. So they're gonna put a bin of parts in that are all jumbled around.
Yep.
No particular order. The robot's gotta figure out location of the parts, and then are they gonna stack them in the other bin neatly?
It's going to stack them in the bin neatly after that, correct.
So what type of industry is that working for?
So this is actually for a customer that's making, let's see if I can describe this properly, right? They're making metal components for oil and gas.
Okay.
And they're making these pieces, and then they need to do something with them after they make them. There's a secondary process that they need to go through.
Okay.
And that's what this cell's doing. This cell's taking the made piece, finding it in the bin, taking it to the secondary process, processing it, and then stacking it nicely in the outfeed bin.
So what's with the black box and the lens on top?
So that is actually the bin picking solution that FANUC offers. So it's a projector in the middle. The big box is actually a projector. There's a camera imaging it at an angle. So we project a pattern onto the parts that are in the bin, and then the camera images it and finds, based on that shape that distorts when it projects, finds the top pieces. So that's the solution that's helping us actually pick the bin.
So that's looking at the parts and doing that part, and then the robot's taking that information and then determining where it needs to go from there.
Yeah, exactly.
Okay.
Exactly. These guys are actually working on it over here.
And how fast would this, once this solution is done, how many parts is it turning through? Is it going slow or is it going relatively speedy?
It's probably a part every few minutes. I don't know the exact cycle time of this, but it's able to bin pick relatively quick, within a few seconds.
Okay.
And then that part has to go to the secondary process. That takes a minute or so. And then it's going to put that part in the bin.
Ryan, what's with the giant doghouse looking parts over here?
Let's go take a look. I'll show you what they do.
You can fit inside of them.
They're essentially automated scrap weighing systems. So we have a customer that wants to maintain traceability for their scrap, because they actually get money for their scrap when they ship it. Okay. They want to be able to track it. So these are actually installed where a customer's employee can badge into this, dump their scrap, and it actually records by employee who's putting what scrap into the bin.
So are these turned up? So is this the bottom of it, and it gets flipped up and it goes in?
No.
This is the top.
They'll actually dump through the bigger slot. Yeah, right here.
I mean, that's got to be. I mean, weighing scrap has got to be extremely important to those companies, right? Because they're trying to recoup that cost of the material. So you guys got to be very accurate with this, or how does that work?
Yeah, they want to be accurate to within a few tenths of a pound. Mm-hmm. But really, it's when they're shipping their entire scrap out, and they're talking thousands of pounds of scrap. Every pound or two can matter, and so if they're not capturing that, and it gets to the scrap people, they say, well, you sent us 2,000 pounds. They say, no, we sent you 2,500 pounds. Now there's this big discrepancy. Yeah. So this eliminates that discrepancy for them.
All right, guys, so Ryan has to go. He literally is going to Africa tomorrow. So Ryan, I appreciate you walking us through this.
Yeah, man.
We're going to stick around and show you guys some more stuff. But what's with the trip to Africa tomorrow?
Oh, actually going on a mission trip. Going to meet kids that we sponsor in Rwanda.
Very cool.
Yeah.
Very cool. Well, hey,
yeah, be
safe
gone
travels,
for
man.
a while.
I appreciate you showing us everything. Like
Looking forward to it.
We're going to go jump into some things while he's gone and poke around and show some more cool stuff.
My name is Michael Gurney. I'm president and CEO of Concept Systems. I've been with the company since the beginning, 20 years. I was always a tinkerer growing up, so I was the kid that was taking things apart and putting it back together, and hopefully it worked.
So my name is Ryan Wasmond, Sales and Marketing Director at Concept Systems. I've been here for about 2.5 years. I actually got started in manufacturing when I was in my late teens, early 20s. I worked at a design company doing computer science work. I was IT administrator for a design company in Michigan, and the owner of that design company actually told me that I should go visit one of his friends who had a robot that they were trying to program, and his exact words were, "Do you like playing video games?" And I said, "Yeah, I love playing video games." And he said, "This is like playing video games, but in real life."
My name is Michael Jeffers. I'm a panel shop technician. Been here for about 9 months now. Yes, I got started for manufacturing pretty much when a buddy of mine noticed that I had an interest in technology.
My name is Jerry Flynn. My title is Principal Engineer, and I have been with Concept Systems for 6 years. What I like about the manufacturing industry are the many different challenges and opportunities to see different things and see how they work and see how they're made, and it just gives me a new appreciation when I go places and I see things and I know, hey, I know how that was done, or oh, that came off one of my machines. It's just a good feeling.
My name is Evan Gonerman. I am a controls engineer here at Concept Systems, and I've been here a year. I was really into math. My dad was a math teacher for 30 years, so I really just liked math, and that brought me to mechanical engineering. And then it was kind of in college that I started working with robotics and kind of, automation in general, and that's when I kind of started to see, like, this is where the fun's at. this is where the good times are.
My name's Mariah Biederman. I am a software engineer here, and I've been here for 2 years. For robotics, I really like what they enable us to do that we wouldn't otherwise be able to do. I think robots are fascinating because in trying to improve and perfect them, we essentially are looking at how to kind of reproduce and recreate ourselves, things that we understand, like sensing and manipulating things, like using your arms and maneuvering around things and getting things done. So we're trying to have this like introspective definition, we're trying to look introspectively and think about how we do things, and then trying to recreate that with some engineering device and producing that in a way to make our entire society more effective and moving it forward.
The reason I've stuck with it is just the constant problem solving. I love puzzles. I love challenges and overcoming those challenges, and so that's been really rewarding to see somebody tell you it can't be done, and then you do it, and then it's done, and it's fun for me to say, look, we did it. What else can we do?
You don't get worn out here because you're always doing new things. You're always seeing different manufacturing processes rather than the same thing over and over and over and over.
What does it for me is just the ability to create something with my hands and see it as a finished product, and just see something that I built be utilized. It's really, it's rewarding.
There's something fun about walking into a facility and literally seeing how something is made. I've walked through castings facilities, watching them pour liquid metal into ceramic crucibles and turn that into a part that goes on an airplane. Or I've seen big pieces of metal heated up in a furnace and smushed into a shape, and ultimately that thing turns into this really, it was a piece of metal and now it's this spool that goes into a jet engine. I've been in facilities where they make glass bottles, to see the millions and millions of glass bottles being made, and just understanding that the broad impact manufacturing has across the entire world is pretty cool, I'd say.
You will be able to have a hand in so many different industries and seeing how things work, what doesn't work. And it really just offers a jumping off point for along the line, if you find something that you're like, I really am interested in this certain industry, you have a hand in it, and that's pretty rare.
It's the future, right? But it's the present, actually. I think that's some of the coolest aspect of robotics, is that for so long, I think it's been this thing of the future, this sort of, unknown futuristic thing, but it's really, it's right here and right now happening all around us. It's like being able to control a toy. You know, like sometimes I'm working with some of these machines and I feel like a little kid because I'm like, oh look, the thing moved. I got it. I pressed the button and it worked. And it's like super exciting because it's this tiny little thing, but you can make a lot happen. You can just with these tiny little bits of control, you can actuate stuff that just kind of blows your mind, you know. It makes me feel like a kid.
If you like to build things, why not get paid for it?
Yeah.
You know, when you look at manufacturing in the U.S., there's automotive, there's aerospace, there's food processing, there's metals and mining. The variety is tremendous, and applying technology with the pace that technology is advancing, the growth potential is exponential when you combine those two.
I think there's a lot of opportunity for you to get on the floor and build a machine, to program a machine, you know, to help make things that make the world go.
This really just gives an opportunity for continuous growth, and it's really just up to you how much far you want to go.
I had a 2-year degree in computer science, and I got that opportunity to start programming robots. That led me down a path of being a problem solver, being on the manufacturing floor. I'm in an executive role now, helping manage this company. I don't have an MBA. I have the technical skills that's required to help solve these problems, and so you know, you could literally start from a 2-year degree and just working towards doing a great job solving problems. You can move into a position where you're now affecting 100 people helping solve problems.
One of the big things I see today that I think basically all kids that are in it and interested in it is the first robotics stuff, and a lot of the robotics competitions that go on today. Anyone involved in any of that, I think going into a manufacturing or engineering position is just secondhand. They're doing it for fun right now. They enjoy working with motors and robots and things along of that nature, and it fits right in hand with what they could be doing daily when they go to work.
So it's a very exciting field, a lot of variety and a lot of room for growth, and job security long term. It's not going anywhere.
All right, guys, so hopefully you got some value out of that. We saw industrial automation, how it's applied to the food industry, aerospace. We saw panels being made. We saw some robotic equipment and how everything comes together to make these systems. So hopefully you got some value out of it. If you like this content, hit that like button, share with one person you know, and hit that subscribe, and we'll see you on the next one.